Right, so yeah, if you connect the bulb up to the DC terminals there, and come around here so your audience can see you, because as all students know, they have to demonstrate from the back.
Just check his pat tested.
And then if you turn up the voltage to 10 volts.
10 volts? What is this voltage?
What's this voltage? Just talking about. It's got a voltage indicator there.
Yeah, but what is that thing?
Well, that's what I've said turn up the voltage to 10 volts. I'm not telling you what it is, you're just seeing the effect of it. Right, okay, you've turned it up to 10 volts, you've seen the effect of it. Right, okay. If you could, here's a voltmeter. So if we have the voltmeter, and we put the voltmeter into 0 to 10, if you put that across that light bulb into those two terminals across the light bulb, let's have a look and see what that is saying to us. Right, that's also saying 10 volts. So the power supply is saying 10 volts. The light bulb seems to have 10 volts across it. You happy with that?
So there's 10 volts flowing through it.
No. We're not saying what it is.
But just supply says 10.7 there.
Yeah, it's just on the right-hand side. Okay, well, near enough, 10. That's good enough. We can round off. We're not. Okay, so that's very good. Thank you very much. Okay. Right. Now, in an earlier session, we used the rope model. Right? So, Tom, would you like to come and show people what the person who's the battery does? And Natasha, could you come and be the light bulb in the circuit? Right. Okay, so Tom, what do you do? What do you do to show that you're modelling what the battery or the power supply is doing?
I apply force.
You apply a force. at the moment,
Bulbs glow.
at the moment, Natasha is actually resisting that movement of that rope quite a lot. Yeah? And now she doesn't seem to be resisting it so much. Are you happy with that? Maybe the bulb resists in a similar way.
Can't see the wires moving.
You can't see anything moving in the wires. No, you can't. But we're modelling what might be going on. Okay, so so if you pulled harder, what would you be doing that we did earlier?
Turning up the voltage.
Maybe turning up the voltage. So
Fine.
you're saying that that pull on there is like turning up the voltage. If you turn up the voltage, do you notice anything more?
Yeah, it hurts my hand.
All right, give them a clap. Right. So you've noticed that turning up the voltage, what did it do as far as that rope was doing? What was it doing in terms of going through your hand?
It's making my hand hotter.
Because, why do you think it was making your hand hotter?
Faster. Yeah.
It's maybe going through your hand faster, okay? Right? Okay, right. So, Tom was providing something that was eventually given. Some of that was maybe given to Natasha. Yeah? Okay, right. Thank you, you're the next volunteer.
Great.
Okay, what I'd like you to do now is make a break there. You can come around here. And what I'd like you to do is to put that second bulb in series with the first one.
What do you mean?
In the same loop. So you
I can't do that with just two wires.
No, but you can pick another bar up. Right.
We didn't get this abuse.
You don't.
That's the reason I went first.
You're not that. Right. Okay.
That's not me, I didn't break it.
No, no. Right, okay. So, what do you think maybe is happening now? Because that bulb is alight,
Yeah. And that one
that one's quite bright.
That one was quite bright.
Electricity.
Right, okay. So, in terms of maybe two people holding a rope, what do you think they'd have to do to model that difference?
No idea.
Right, okay. I'm going to be the battery. You're going to be the two bulbs, two hands. Yeah, two hands. Right?
Do around his neck instead.
When I pull that through,
Yeah.
what would you do so that one hand's going to warm up more than the other?
Hold it tighter.
Hold one tighter and one looser. Yeah?
Yeah.
So which one of those has got more resistance?
This one.
This one.
Left.
And that heats up more.
Yes.
So of those, which of those bulbs do you think has got more resistance?
The bright one.
Okay. Right.
So
Right.
Jerry, are you saying that the first bulb was holding it as tightly as it was before?
Am I saying?
Are you saying that the dim bulb is now holding it as tightly as it was before?
It's changed.
It's dimmer.
Am I saying that first bulb hasn't changed? There's the same resistance on that one.
It's dimmer.
Yeah. But we've got a second bulb in.
Yeah, but
The
it's
second bulb.
But it's dimmer, so can't be holding it as tightly.
Yeah. Why not?
Because the other one's holding it even more tightly.
Okay. What about the speed at which this went through?
It's slowed down.
Okay.
But that bulb's really
That's
bright.
because we're gripping it twice.
Yeah, but look, that bulb's really bright. It's as bright as the first one was when we started.
Yeah. You're being devil's advocate. Right, okay.
It's also
Gerard,
made the
you're a
boxes short a bit.
gentleman. Right. Okay. So put the voltmeter across one of the bulbs.
So say that again.
Put the voltmeter leads across one of the bulbs.
One of the bulbs.
Yeah.
It's glowing a bit, you can't see it from there, but that one's actually glowing to an extent.
Yeah, it is. Okay. You've got about how many volts?
About 8 volts across that
But
one.
that's about 10 volts. It's class of what?
Assuming not really not it isn't.
Okay, right. Take the leads out. Take the leads out of that one, right, and put them across the other one. Okay. And that's going up to about 2 volts. 8 volts there, 2 volts there, 10 volts total.
Does that mean all the electricity is getting used up in the first bulb?
Used up. Why should any?
That, I had 8 there, but it's only got 2 minutes for the second bulb, so it must have been used up.
There's 10 volts available from the power supply.
If you do that,
8 volts are available across.
maybe it is.
Yes, across the two. We've got all 10. So all 10 volts. There's 10 volts across the two, 8 volts across one, 2 volts across the other. It seems that voltage, when in the circuit, it adds up to the total you started with. We've not said what voltage is, but we're just saying it adds up, and it must have something to do with this brightness, this, dare we say, energy. Okay, how many minutes have we got left?
-2.
Okay, that's good enough for a start. We could have gone on to think about other sorts of resistors and flow with them and another model. So, which do you think it will be easiest to blow the air through? The shorter one. This has got more resistance. We can feel that. How do you get the air through it? You have to have a bigger pressure at that end than that end. A pressure difference will create a flow through a resistor. Anyway, we could develop another model. Anyway, we're not trying to tell people exactly what it is, but experience to get there.
Okay.